Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we have a Mac SE30 motherboard that is not working. I recently looked at this on a second channel video, and I found that when I powered it up, we just had these kind of vertical lines, and the thing wasn't working. So I want to get this hooked up to my test setup that I have on the bench here ready to go, and use the oscilloscope to try to troubleshoot and figure out what exactly is wrong with this motherboard. So without further ado, let's get right to it. So the Mac SE30 motherboard. What's cool about these motherboards is they're pretty fast for compact Macintoshes, sporting a 68030 running at 60 megahertz, a Mathco processor, and they support up to 128 megabytes of RAM when you fully populate the RAM banks here. You can often put one of these motherboards into a regular Mac SE case as well, so it's a really nice upgrade that gives you a very significant performance boost with those old original 8 megahertz SEs. Now in that second channel video I mentioned that I did the troubleshooting on, I was testing out this KMac vintage video power supply adapter here. You can plug this into an SE30 and then you can turn it into a desktop Macintosh. In that video, I figured out that the video ROM had gone bad. It was this chip right here. It had become really hot while the machine was operating. In addition, this 6522 got super hot as well, although it seems okay now. And I did a little bit of other troubleshooting where I put Deoxit in the video RAM socket. And when this motherboard is powered up, hooked up to an RGB to HDMI, or I guess an internal screen on a Mac SE30, you get vertical white stripes mixed in with a gray alternating dot pattern, which is normal when you first turn these machines on. You get sort of a gray pattern until the system initializes and then boots up all the way. Also, the reset button doesn't appear to do anything when you push it, so that could possibly be an issue as well. I didn't really go any further with troubleshooting than just this stuff in that last video. So I think the first thing we're gonna do is hook this thing up to, well, my little test setup here so we can see if it still has the same symptoms. This board here is a Macintosh SE analog board, although it came out of a dead machine and had the battery explode in it and the power supply was all damaged. So I removed the power supply, I removed the flyback transformer because that was good and usable on fixing other machines. And the way I'm going to power this board up is using this little board right here. This little adapter board here is designed to replace the original Aztec or Sony power supply that's on these boards, and it plugs right into the connector right there. And this is part of the PicoRC line, and this is an open source project that has all these replacement power supplies for various vintage computers. So when you connect this up to the board, what happens is it replaces this big power supply that would normally be here, which can often fail or whatnot. And then you can plug the original cable into your motherboard to power up your Macintosh SE or SE30. If the rest of this board were complete, then it would also run the CRT portion of the board as well. So it would be actually running the high voltage and stuff like that. Although, as I mentioned, the flyback's missing from this board, and I actually removed the little IC right here, which takes the video signals out of the Macintosh motherboard. And what I've done is I've just fed them directly into this little adapter board here, so I could plug it directly into my RGB to HDMI. I did test this with a working motherboard, a Macintosh SE motherboard, and when it's all plugged in together and we hit the power switch here, then it actually powers up the motherboard and we get the video output from the RGB to HDMI. Now, I'd mentioned in the previous video when I worked on this machine that I had recapped it, but the motherboard was otherwise untested. So you can see I have MLCC caps replacing all the leaky electrolytics, plus I washed the board and cleaned up any kind of corrosion that might have been there. And whenever I do a recap on a board like this, even though I haven't cleaned up the flux here, I always inspect to see if any of the traces are broken, because a couple of them, like these right here, run underneath these capacitors here, and you need to make sure they're not broken, and if they are, you should put a bodge wire before you reinstall the new cap. You can see little spots here where it looks like some of the cap juice has leaked under the solder resist, and potentially we have broken traces there. Although I don't necessarily think that's the problem, but it's definitely worth investigating if I do some basic troubleshooting on this thing and can't quite figure out what's wrong. So yeah, see those little dots right there? We would just need to uncover those just to see if those traces have good continuity. You can definitely see signs that there was a lot of the capacitor juice all over this area of the board as well from this leaky cap, which I've already replaced. But generally, this kind of stuff is not a big problem. You might also be noticing that I have my new blue mat on the bench. And yeah, it's a proper ESD mat that covers my entire bench, and it was given to me secondhand, which is why it's got some scratches and scuffs in it, but that's perfectly good. This mat was actually in the process of being thrown away, where someone grabbed it and thought, Adrian could use this, and sure enough, I could. So yeah, no more old beige mat that was on the bench. So for anyone who was used to seeing that beige mat, there's going to be a little bit of a getting used to period for this new blue one. Since the last time you've seen this video, I removed these 4 SIMs just because we might be using these pins here for troubleshooting. And I've gone ahead and removed the ROM SIM as well, which normally sits right here on the motherboard because I know this one works. I tried it in another board, but just in case, we took it out just so we can probe around and see what's happening on this board. So first things first, let me power this thing up through this contraption here and see if we're still getting that same effect with the vertical stripes. All right, here we go. Let's see what happens when we turn it on. Yes, looks a little bit different as well. We're kind of getting some dots and a little bit more of a messed up appearance. Pushing the reset button doesn't seem to do anything, and it's basically where we were before. Let's power cycle it one more time. Yep, it's acting exactly the same. If we bend the board and do things to it, nothing really happens. This chip up here was getting really hot, and you know what? It's doing it again. That's interesting. The 6522 there. Yes, very, very warm. Now going back to my original note here, the 6522 at UK12, that's this one right here, and the EPROM, which was super duper hot when this one was installed and this chip is now damaged. The thing that these two chips have in common, and in fact, a lot of these other chips that have the little dot on them, is that they share the same set of data bits. The system is a 32-bit system, of course, but there are peripherals that are designed for 8-bit systems, like the 6522. So this chip and the EPROM and this chip and a bunch of other things and one of these SIMs, and I think this SIM as well, are using the top 8 data bits from the CPU. With a little bit of Googling, I found a copy of some schematics for the SE30, and these are very low quality scans, but you know what? It's a lot better than having nothing. And if we take a look at the first page, there's a 68030, and there are all the data bit lines, D0 all the way through D31. Over here on this page, there's the EPROM for the video ROM, the 2764, and you can see that the data bit lines that it's on, which is Q0 through Q7 on the chip itself, are connected to D24 through D31. And that seems to be a very common thread if you look at all the other peripherals on the system. Like here's this 8530, whatever that is, and it's also on D31 through D24. And this chip right here, which I think might be the sound chip or something, or part of the sound circuitry, it's also on 24 through 31. And yeah, I think it's sound circuitry because a couple of these lines over here make their way to these Sony sound chips, and there are 2 of them on this board. And then this is UK12, which according to my notes here is the chip that was getting really, really hot, and it's also on 24 through 31. So all of these chips seem to share the same data bits, and that kind of leads me to believe that we might be having an issue specifically on those data lines. And then when it comes to the video circuitry, it's using these 2 NEC video RAM chips right here. It does not use the SIMs on the motherboard for the video circuitry, unlike the other classic Macintoshes. This one has dedicated RAM chips specifically for the VRAM. And when we look at the schematics for these chips, it turns out that these are actually dual-ported video RAM chips where each of the 2 chips handles 4 bits. And there's 2 separate sets of data bits lines. There's one set that goes towards the CPU and the rest of the system, and then there's another set that goes towards the video circuitry itself, which happens to be, I think, a bunch of PAL chips in the case of this system, or at least there's a shift register here, and I think it makes its way over to a PAL chip. So when we look at the 2 chips here, we have those same data bit lines. This one has 31 through 28, and this one's 24 to 27, and then it has the video output circuitry that goes over to the rest of the system. Now remember, we're seeing those vertical stripes, and the weird thing is we're seeing the gray pattern we should be every 4 pixels, and then we're seeing just solid white on the other 4. So that kind of implies to me that there's some kind of an issue with at least one of these chips, whichever of the chips it's handling those parts of the screen, those vertical stripes that are solid white, and the other one, I guess, is maybe working okay. So this kind of tells us that there's definitely something in common going on with, well, that chip which gets really hot, the EPROM, which, well, it killed this EPROM, and maybe this one's dead too, I don't know, and one of the 2 video RAM chips. So I think what I'm going to do is I'm just going to remove everything from the board that is in a socket and that's on the data bus, and that would be the EPROM there, and then the CPU. I'm just going to grab a a little lifter tool here for the CPU. If the CPU is not pushed in too far, then you can use these pins, but it does seem to be like it's pushed in a bit too far, so I'm going to try to lever it out a little bit, and then I can use this Intel chip lifter thing here, and there we go. That is working now. So we just put this in there, tilt forward, and this should lift the CPU out. The reason why I'm taking this out is because I'm eliminating any potential issues with the CPU being a problem or the EEPROM there. Now this particular board uses these PAL chips here to do a lot of the heavy lifting. Now a lot of it's actually happening inside this chip as well, but these also do a bunch of the lifting. But taking a look at these chips on the schematics, it doesn't look like any of these are actually connected to the data bus lines. There's address line stuff that goes into these, and I think this chip as well, but no data bus line. So I don't think these chips are in play here with what's causing the issue here. It's something else on the board here. So I think the first thing I want to do is start probing around on the data lines on these two chips. I don't know which one of these is responsible for the white stuff we're seeing on the screen versus the pattern, but what I can use is I'll just clip this on here. This little chip clip just makes it easier to probe those pins. And according to the schematics, the output pins on this chip are pins 2, 3, and 22 and 23, which I assume are just over here on this side. So let's probe pin 2 and just see if we're seeing solid white or we're actually seeing some kind of a pattern coming out of it. So we have the oscilloscope here. Let's see what we see. Okay, that looks like a pretty normal looking pattern. So I'm gonna say that this one is probably not screwed up. Let's clip onto the other chip here. See what we see now. Aha, that doesn't look quite so normal, does it? Let's go back to that first one there. So that just looks like a nice gray pattern. And if we move over to the next pin here, which is pin 3, same thing, just a nice clear pattern. And I'm assuming over here is 22 and 23. Yep, looks good. And move back onto this lower chip here and we turn it on. Yeah, that does not look quite right anymore. I'm gonna say that that's that white stuff with that weird pattern that's moving around in it. Okay, so I've identified that this is the suspect chip. I'm gonna grab a marker here. I'm gonna put a little, I don't know, question mark on there, just so we know that that chip there is the one that's potentially suspicious. So according to the silkscreen markings, it looks like we're looking at UC6, this top one here, versus UC7, which is the one that looks like it's working correctly. So on UC6, the data lines we're looking at are 28 through 31. So we'll clip this back onto here and we're gonna look for pins 5, 6, and 19 and 20. All right, so I'm on pin 5, which is data line 28. Let's bring this back up. What do we see? Oh, we're looking at 1.51 volts, which might be okay. The data bus might be floating. The CPU is not even installed right now, so maybe nothing's driving the bus. So that might not be a problem in and of itself. Now I'm on pin 6. Looks like it's just floating. Okay, now I'm on pin, well, what I think is 19, data line 30. Same thing. And now I think I'm on pin 20, which is data line 31. What the heck? 12 volts? Okay, so 12, wait, I need to validate, I gotta revalidate what's happening there. So we were seeing what looked like 12 volts on that pin. I'm gonna move this clip onto the other chip, just in case. Well, we know this is a problem because this chip doesn't have 12 volts going into it at all. This is like a normal chip here. Yeah, this can't be right. So that was pin 20, data line 31. Let's look at data line 27 on the other chip when we turn this on. Yeah, like 1.5 volts. So, well, that's very, very problematic. That is bad. That is really bad. What that almost certainly means there's a physical problem on this board somewhere that is shorting the 12 volts to data line 31. And unfortunately, that kind of means that everything that's on data line 31 is probably dead. The CPU, the math coprocessor, the floppy controller chip, the sound chip, the SCSI controller chip, that's these two right here, the two vias. I mean, this is bad. This is really bad. Is this something that I did recapping this board? Wow. Wow. Okay. And the worst thing is I've run this board quite a bit, you know, trying to troubleshoot it, which means I kept feeding 12 volts into those things. That's almost certainly what killed this original ROM chip. Probably killed this. Probably killed the SIMs as well. There would be one of, well, 2 SIMs out of the 8 that are connected to data line 31. Oh boy. Oh boy. Oh boy. Okay, I think the first thing I need to do is I need to see if it's just a dead short to 12 volts. I'm sure it is. And looking at the schematics on the power connector here, it is pin 14, that's plus 12 volts. It's only on pin 14. There's only one pin there that's actually on that line. And I can see on this connector, that's pin 1, that's pin 8, 9, 10, 11, 12, 13, 14. Yeah, it's this pin right here. And let's go to continuity mode. Yeah, 0.56 ohms. Oh boy, that sucks. That really sucks. Now, thinking about this particular problem, wow, there really aren't many things on this board that are actually hooked up to the 12-volt rail. It goes to the floppy drive connector here, and this connector there. I think it might be used for the sound circuitry over here, like something in the sound circuitry is also on the 12-volt rail, but I think that's pretty much it. I think the best thing to do is to look on the schematics here and just try to figure this out. So 12-volt rail, it goes to pages 1 and 6. All right, here we are on page 6. Can I find, this is not a searchable PDF, so I have to find where the 12 volts is. Okay, here we go. Here's some sound circuitry stuff. So there's 12 volts there on the sound circuitry. Now the op amp is not connected to any kind of data line, so it's not coming through the op amp itself, but see these capacitors that are around it? Some of these might have been ones that I replaced, and it could be that there's a short or something happening underneath one of those somehow. In fact, I think it's these over here that are the ones I replaced. C3, C5, and C6. Yeah, and also C4. Now, when you look at these on the schematic here, there's no 12 volts anywhere around this area, but that doesn't necessarily mean that like this trace here that's hooked up to the 12 volts doesn't somehow make its way over underneath there or near a trace or something like that. Now, the other thing is that we look at these sound chips, which are also near these capacitors that I replaced on the board, and there isn't necessarily the data lines, but the data lines are over here near this sound chip, which would have been damaged as well. The reason why I'm looking at the schematics here is I want to see if there's a chip hooked up to 12 volts and also hooked up to the data lines, because maybe it's shorted internally, or there's something like a little piece of wire or something that's laying up against a pin. But I really don't think on the Macintosh here there's any ICs that actually run on 12 volts. I think everything is a 5-volt logic. And again, the op amp over here is running on 12 volts. Well, on the power connector, C10, this would have been a cap I changed, 47 microfarad. Let's take C10 off the board and see if we can see anything that's obviously gone terribly wrong. And I shorted something there. That's probably the first place I should look here. Here's C10 right here. This is on the 12 volt rail. I got to remove that from the board. I think at this point, this is definitely something that I surely did to this board. So there's the capacitor removed. And a little bit of IPA on there. Let's clean this, try to see what happened here exactly. Well, you know what we can do actually? We can see if the short has cleared just by removing that from the board. Okay, we're on pin 20. Make sure I'm on continuity, I am. Yeah, the short is no longer there. So absolutely, it was something right here. And see how see that little bit of, yeah, like right there? Maybe that's, is this 31 right here? Let's see, is that exposed, that trace? Let's see. No. I gotta clean that a little bit better. I can't really see what's going on there. Definitely looks like a little bit of the solder resist is missing right from that trace there. And there it is. That is absolutely it right there. So that trace is data line 31. And I guess I had that MLCC. I had it just sort of touching somehow. Wow. It's one of the dangers of using these. They have wider connection points than the original caps, which only connected to the pads right here. And that's this data line 31 obviously makes its way right by these. And I guess that cap was just slightly at an angle. Okay, well, all I can do is put a little bit of lacquer right there where it was exposed. And I'm going to reinstall that cap once this dries, that is. And we'll see how horrible the carnage is on this thing. But I'm kind of predicting that we have massive damage to this board, unfortunately. Just thinking through what's going to be damaged on here. Floating point unit, CPU, the ROM, I can make another one of those. Some of the memory, the sound chip here, the SCSI controller, and I think that's like the serial port controller, or maybe these are doing that. The Apple desktop bus chip might be damaged as well. I mean, yeah, many things are going to be potentially bad on here. But it is fixable, and the reason why I say that, I happen to have this, which is a Macintosh 2CX motherboard that definitely, well, seen better days. Luckily, the SE30 and this are basically the same. The only thing that's different is this has NuBus on it. And obviously this has some built-in video to drive the monitor, but otherwise we've got a lot of similar chips on here. We have the VIAs on here, which are, I think, down here. The ADB chip down here on this one is pretty crusty. That's this chip over here. I'm not 100% sure if that one might have been damaged. We obviously have a math code processor we can steal. There's a processor here that is soldered on the board. I think I have another spare we can try of that. We have a sound chip we can steal. There's a SCSI controller we can steal. There's all sorts of good parts on this board, and it's perfect because this thing is obviously never going to work. But hey, if I can use this to fix my mistake on the SE30, then that's awesome, right? But before I jump to any conclusions, I'm going to reattach this capacitor here. And of course, I'm going to double check to make sure that we are not shorted any longer. We're good. I'm thinking here that the only real issue might be the RAM chip, to be honest, the one here that was hooked up, because that motherboard that I just showed, the parts board, doesn't have this chip on here. So it could well be that I'm going to have to go try to find and source one of these ICs, even if I can replace the rest of the damaged components. All right, well, it's time to bench test this again. Now, I don't have the CPU. This thing's never going to run, but I just want to see if the pattern looks the same, hence the damaged video chip. No. That is how a Mac should look. Right. Okay, so Mac SE's 30s, when they're not running, they look like this. So I'm going to reinstall some components on here. In fact, I'm going to put them all back in. And let's see if this thing could have somehow survived this basically torture that I was giving the board. I mean, there's just no way this is going to work, right? There's just no way this could possibly work. So here we go. Nope. What I should probably do now is we should hook up to the address lines and see if there's any activity on the CPU. The fact is the CPU may well just be completely dead. So I think it's probably a good first step is to just swap the CPU. Without a working CPU, right, there's no way this machine is going to ever do anything. So I don't confuse things, I drew a question mark on the CPU that was in this board. I went into my parts and I found this 25 megahertz 68030. Just double checking the pins aren't bent. They look okay. Let's get this in here and let's see what happens. Okay, we're getting nothing. Wow, hitting reset. Did that have an effect? No. I put the EPROM clip back on. Let's just see what the data lines look like now. Aha, there's activity on the data lines. So let's get the voltage looking right. Okay, so this is one of the data lines, and instead of just floating at some random thing, it's actually doing stuff. Let's just check these different pins. They are all looking okay. And this is one of the address lines. So there's definitely activity on this machine. It's trying to run here. It is trying to run. Okay, it looks a bit different. What happens when I push the reset button right now? I think I gotta check to see if this button even works, because that was the non-maskable interrupt button there that did that. Let's hook up a speaker. Where's a speaker? Let's see if this thing makes any sounds when I power it off and on again. Well, made a click sound, but we're still just getting that same gray pattern there. You can see that right there. All right, let's see, what's getting hot? 6522 is not getting hot. Let's see if the EPROM may well be damaged as well. You know what I need to do? I should grab one of the working SE30 motherboards, and I want to put this ROM sim and the video ROM and the CPU. I'll put the CPU that might have died here onto the other board, and let's just see if it can run with those parts. All right, this is one of the working motherboards here. There we go, we got a chime. So it is functional. And let's see, yep, there we go, we got a cursor. And if I hit the reset button, we get a white and then a black screen, kind of flickers and stuff, and it reboots normally. Okay, what we can do now is start swapping parts. So let's put the ROM sim from the other motherboard onto here, because without a working ROM sim, we're not gonna get anything. Could it possibly have, whoa, this ROM sim survived 12 volts on the data line, and I'm pretty sure, yeah, it definitely is on data line 31. So that's cool. Okay, so we know that ROM sim is good. Okay, I'm just swapping over the video ROM. This is the one I made. Does this work? It works as well? All these things seem to be surviving. Wow, there are actual survivors here. Okay, I just had a thought. What I don't know for sure, does it need RAM in that first set of slots here? For troubleshooting, I took the memory out of this bank here, but is it possible that it needs those to work? It says Sims 1, 2, 3, and 4, the banks, the way the banks are. So I don't think you need memory in these. Almost certainly, it just needs at least 4 memory modules in these first 4 slots here. Although, I guess it's possible that one of these is dead because it was getting the 12 volts going to it as well. So maybe I should swap these out. Let's test the CPU that might have died. That was this one on this board here. Let's just see if this is a good CPU or not. Okay, so out with the one from the board that we know works, and let's put in the one that got exposed to 12 volts and see what happens here. That freaked me out. That really freaked me out. So I think that's a sad Mac tone in a horrible, in a very, very unhappy way of working. So I'd say that this CPU is bad. That's what we're seeing here, is we're just seeing absolutely nothing. I think it's trying to play the unhappy Mac tone. That's hilarious. It's so scratchy sounding. Okay, I'm going to get an X on this CPU. So this is kind of the problem we have now, is it's really difficult to know which peripherals are damaged on the other motherboard that are keeping the system from working. Now, one thing that is needed for the CPU to work correctly, or the system rather to work correctly, is one of these two 6522s, we have to look up which it is, actually has a ROM overlay function. So as soon as the system starts to boot, it actually relocates the ROM to a different part of the memory map. And if it's damaged, especially the one that was getting really hot, then I think that would also keep the system from working altogether. Okay, I put the good CPU back in. Let's make sure the system still works. Yes, got a good chime. Okay, so first casualty right here. You know, in thinking about it, this is the parts CPU I put on here, 25 megahertz. I don't even know if that works. The ROM is good and the sim is good here. All right, so back on the damaged motherboard here. Let's see what it's doing right now that I've sort of taken those things in and out again. Okay. Seemingly nothing. Yeah, basically it's working exactly the same as before. Now that is exactly what it would do if the CPU weren't working, so I am gonna put in the CPU from the other motherboard just to double check in case this is a bad CPU, and then if it's a good CPU, I don't know why I didn't just test it a moment ago. I should have. Okay, this is the motherboard that's working, plus the 25 megahertz processor here. Are we getting that wonderful, nice chime that we hear on Macintoshes? Here we go. Okay, yeah, good, that's a good CPU. So I'm just gonna draw a tick mark on there just to indicate that it's absolutely a good chip, as is the one, of course, that was originally on this good motherboard. Now, the thing to consider here is that if the device, like say the Mathco processor, were never turned on, like was never selected, maybe it's okay. Like the CPU probably was trying to read the bus, so then it was reading 12 volts right into that input, and that's just bad, right? You know, it's not gonna like that. But maybe the ROM was never selected, and the ROM normally just outputs, right? It doesn't read anything, it's only sending onto the bus. And the same with the ROM sim. And they seem to be okay. But a lot of the other peripherals do communicate both directions on the bus. So if they were selected, then they would suddenly be receiving that 12 volts right into the chip and, you know, bad things. So one last test here with the damaged motherboard with the good CPU, good ROM, and good ROM in here. I just get clicks out of this, but no sound of any kind. Right, so let's figure out here with the RAM, which ones of these sockets here are on 31. I have a feeling it's probably this one right here, this top one. And I have another sim here. I think it's exactly the same type too, Toshiba. Well, the one on my right hand's made in Germany. This one's made in Japan. I think they're the same otherwise. So let's just pop this in. I don't think this is going to do it. I think the machine would give us unhappy Mac sound if there was a problem with the RAM specifically. Yeah, no change. Okay. I have a feeling the RAM is probably okay. Now, just incidentally, pretty sure this is the RAM here. Sim 3. Sim 4, so we were looking in Sim 2. This was, oh yeah, Bank 0, by the way. And do we have the data line 31? Yes, we do. There it is right there. So it was that sim that I just took out of the board. That would have been the one that potentially got damaged. Okay, what I want to do next is look at the reset circuit. So this is the headphone output jack, stereo on this machine here. There's the audio output that goes to the internal speaker. That's the little amplification part of it. And we have these two Sony sound chips here. Now these handle the reset, and they have on Macs since the very beginning. And it's this signal right here, 5, that is the output of the reset signal. And the sense signal right here, 6, I'm quite sure if we follow this, this probably goes to the reset button. There it is, right there. And there's a couple resistors and stuff. So let's take a look at pin 5 on this UB11 and just make sure that when I push the reset button on the machine, it's actually toggling. Okay, so that's pin 5, and if I push reset, yeah, nothing happens here. I think the button is bad. I wouldn't be surprised if that's what's going on. So let's go back to here. Sense is pin 6. And if we look at 6 and I push the button, nothing happens. If I push it really hard, it starts to do something. Okay, so this is a physical problem with the reset button. I'm going to put some Deoxit in the socket, or in the switch. So we'll just feed some into here, like so, and I'll just push it a whole bunch of times. Okay, let's turn this on and try again. Is that normal? Maybe it is. We could check by just looking at the output of this Sony sound chip here. And when I push the reset button now, oh yeah, okay. It does reboot the machine. Awesome. What effect does that have now? Oh, okay, it makes the video go away, which is what I've always expected it to do. But the machine does not come back to life. In that previous video, I pushed the reset button a whole bunch of times, and then we would actually get a working system. Let's hook the speaker up though. Here if it makes clicky noises. Yes, it does. All right, so that's one other problem solved that was unrelated to the damage that I caused on this board. Well, question is now, where do we go from here? I think I'm going to go back to my original notes here. It was UK12 that was getting burning hot while the 12-volt line was hooked up. Let's take a look at what UK12 does on this machine exactly to see if that could be stopping the machine from booting. All right, here's the VL1 UK12 65C22. We have data line 31 there that was damaging the chip potentially. And then we have a bunch of outputs. And one of them is the overlay signal. Other signals like head select, this has to do with the floppy drive controller, so it selects side 1 or side 2, because you have to remember the floppy drive controller on the Mac is actually derived from the Apple II floppy controller, and the Apple II floppy controller only had one side, it wasn't double-sided. So it is the 6526 on the Mac that actually drives that additional head signal that goes to the floppy connector. There's also like alt-vid and sync and stuff, and I don't think sync has to do with the video sync signal. That has to do with, like, if you follow this trace thing, it goes to one of the other glue logic chips. We need to take a look at pin 7 though, not pin 7, pin 6 here, this overlay signal. The overlay signal is very commonly used on 68,000 base systems, and it's the same on the Amiga. And what happens when you first power up the system is the ROM is mapped into the beginning of the memory space. And that's because, if I recall correctly, the 68,000 begins executing code from the very start of memory, which is address 0. But the thing is, on most memory maps on machines like the Macintosh and the Amiga, the RAM actually sits at the bottom of the memory space. So what happens is when you turn the computer on, the default configuration has the ROM mapped into that space, and the ROM begins executing. And very early on, the ROM goes and talks to the 6522 in the case of the Macintosh, and it asserts or deasserts that line. We'll have to look at what it's doing, and that will remap the memory, and it puts the ROM somewhere else in the memory space, like much higher up. And then the RAM itself gets mapped into that memory space. It works exactly the same way on the Amiga, and therefore if you take out the chip that's handling that, I can't remember which one it is, then the system doesn't boot properly anymore because of that particular overlay signal that's missing. So on these chips, pin 1 is typically there, and we're looking for pin 6. I don't remember which direction you go, clockwise or counterclockwise. I'm assuming we go clockwise. So 1, 2, 3, 4, 5, 6. So I think it's this pin right on the end here. If it's not this one, it's the pin on the other end is the overlay pin we're looking for. And I guess I'm on the wrong pin, because I really don't think that that's what we should be seeing on the overlay pin. We shouldn't see activity like that. I'm hitting the reset button. No, I'm going to check the other direction. Okay, I'm on, I think, what's pin 6. And it looks like, well, it looks like it's probably working correctly, actually. We're going to have to get the other motherboard out to compare. But I'm pushing the reset button right now, and it's high. And as soon as I let go, it goes low immediately. We need to see what that overlay signal does and what the sync signal does as a comparison. Maybe what we're seeing here is totally normal. I'm not sure. And I just had a thought. If I take out the ROM sim, then there's no way that it will be instructed to bring its signal low. I'm assuming that's the way the logic works. So let's see what it does now that the ROM sim is removed. Aha. It's just high. Well, that kind of tells us that maybe that 6522 is working okay. I mean, it's hard to know, really, but at least the outputs are doing what they should do to remap the ROMs. I mean, one thing I can tell for sure is that the CPU is executing code. So we hit reset, so we have nothing. I let go, and you see that, and then after a little while, it's doing that. And what normally happens on a working motherboard is it's in this kind of state where it's starting up. It's, I don't know, doing a RAM check or whatever, and then it initializes the video and it begins to boot. As I'm wondering if the sound chip is bad, A, which is why we're not getting any kind of sound, but is the system actually trying to boot? And if I push the interrupt button, which I just did there, which is kind of how it looks when you're first starting up, and then it goes back to that pattern. And I'm on one of the address lines, by the way, if I didn't say that. That's what we're looking at right here. Okay, so this is one of the data lines. If I push the interrupt button, that's what we see. It goes back to that. If I push the reset button, we get nothing, and you let go. And we get this, which looks like the interrupt, and then we get to that. Let's go look at the sound controller here. This is this IC right here, UE10. Let's see if this is being selected. So there's a sound select line right here on pin 11. That's coming from the DSLogic chip, I think, which is kind of like the PLA of the Mac. It's this large VLSI chip right here. Let's see if there's any activity here. Like it's trying to make a sound or do something, and maybe the chip is just damaged, and that's why we're not hearing at least that sound. Okay, here we are, pin 10, select line, or pin 11 is what it should be on, not 10. Okay, pin 11, there we go. Oh, yeah. It's being selected. Right, so let's hit the reset button. Okay. And we hit the interrupt button, it right away selects it, which usually on a Mac will make it play the unhappy sound. Well, my assumption here is this chip is damaged. Let's check the read-write line next. What happens if we push a button there? Yep, we see it going low as well, which means the chip is being written to, although that signal is going all over the board. So that kind of gives me a thought that the sound chip got damaged through all of this, because it's on the same data line 31. Okay, I think I'm gonna swap the sound chip over from that parts motherboard. I'm just gonna put a little mark on here, put an X on there, I don't know, might not be bad. Let's swap it over, see if that makes any difference at all. Okay, the sound chip is reinstalled. It's kind of ugly, but I'm not that good at doing surface mount reattachment of these types of chips. Probably there's a better way to do it, but I don't really know how to do it. If it's these types of chips, it's really easy because you can just drag across the legs. But these ones, the legs go underneath the chip, the PLCCs. Not quite as easy, but I think everything is reattached. It looks like it's not there, but that's just a bit of flux. I realize now that when I was probing this with the oscilloscope, I should have looked at the PWM outputs that go to these two chips that go to the headphone jack, just to make sure that, well, you know, there was no sound coming out of these. Bad troubleshooting on my part. I kind of jumped the gun on swapping this. Let's see if this made any difference at all. Okay, here we go. Let's see if this does anything. Aha, it's making some staticky noises. So it's trying to make sounds. Does that come across in the speaker here, in the microphone that is? Now these are the two chips. That's the one I just removed from the board. 344-50063-1, 344S0063-1. I guess it's an S, not a 0. So they are the same exact chip. Let me just double check that I have everything connected properly. There's the dot lined up on the board, so the chip's on there the right way. Let's just double check, see if we can maybe have a bad connection somewhere. I was just checking with the loop. It looks like I do have a couple pins that aren't connected properly, so let me try to fix those. I think it's all back on there. What's gonna happen here? Let's hook this up. Oh, really? Now the system's not even getting to the gray screen. What did I do? I made it worse. All right, well, I obviously did something worse to this motherboard, so I need to double check my work, check for shorts, things like that, because something is obviously wrong. All right, I was poking around. I didn't really find anything, but watch this when I turn the machine on now. Okay, so sound is now operational. So definitely this sound chip I took off the board got damaged along with the CPU. But there we go. That is what I would expect for something wrong with the system. Now you would typically get that if you have a RAM problem. I don't think I ever actually ran this motherboard, right? Like I never really tested this. So maybe what I just need to do is put 4 known good sticks of memory on here. Oh, and I just want to do it without breaking the slots here. So I went into my RAM parts and I grabbed 8 256K memory modules, ones that I've actually tested. So I'm going to put these in. So this thing will just have 2 megs of RAM total. So there we have 1 meg installed. To see what that does. Nothing. Let's pop in this other 1 megabyte here and let's see what happens. No, okay. It's not the RAM. It's not the ROM. It's not the CPU. It's not this ROM. We know the sound chip is good now. Whatever could be wrong? If only we had like some way to tell what was happening with the diagnostic. There's clearly a diagnostic that's running. And maybe it's unhappy, like the math coprocessor is bad, or one of these other chips, and I don't really know which one it is. What's kind of frustrating here is that on older Macintoshes, it actually initializes the video immediately. Well, it doesn't even need to initialize it because it's coming out of main memory. So as soon as the system is powered on, it's actually displaying the contents of RAM. So it's able to write like the SADMAC into that memory and you get like a code. So at least you have an idea of what's going on. But on the SE30, the video circuitry has to be initialized by the ROM, and it's failing at some point before then. And without any kind of feedback as to what's the error, I don't know where it's failing. If I knew where it's failing, then I could just swap that chip out. Like say it was the disk controller or the SCSI controller or whatever. But it seems that that's not the case. Now, the thing is, I doubt it would be initializing things like the SCSI or the disk controller before the video, but I don't really know actually. You know, this is where a custom Macintosh diagnostic ROM would be so helpful, something that could actually give us some kind of feedback as to where this failure was occurring, or even say it just outputted a code over the serial port. All right, well, I've been poking around at the broken motherboard for a while now, and I can't really see anything wrong. The tactic I had as I was trying to look to see if any of the various peripheral chips were being selected by the ROM before we get that sad Mac tone. And the only thing I can see it actually talking to are the two VIA chips, the 6522s. The other chips like the FPU, the disk controller chip, the SCSI controller chip, the serial chip, none of those seem to be talked to when the tone happens. Oddly enough, the serial controller chip does get talked to after the tone completes, and I do notice one line toggle on one of the outputs, as if it's maybe trying to send a status signal or something to the serial port to say, hey, there's an error of some kind. But mainly when the system powers up, I see it talking to these two ICs right away. Now remember, this was the one that got really hot. Maybe what's happening is the CPU is actually trying to talk to that chip and read stuff back from it, and that's failing. And maybe that's why we're getting the sad Mac error. So because this is the one that got super hot, why don't I just take this one off and swap it with the one from that other motherboard? Okay, 6522 has been removed from the SE30 motherboard, the one that was getting hot, and I took this one off of the Macintosh 2CX motherboard. First thing I'd like to do is see what happens if we turn on this machine without that chip installed. I'm not sure we're even going to get any signs of life at all, because that whole overlay signal is going to be missing altogether. Oh, okay, interesting. So the ROM is able to run, but we're still getting that particular sound. So that's actually a really good sign, because maybe it really just means that that chip was bad and I just need to get this one on the board. So let me do that. The 6522 has been replaced. This is the one off the Mac 2CX motherboard. Again, my soldering is pretty terrible, but I'm pretty confident that I don't have any missed connections or any shorts. So are we ready for testing? I think we are. I have to admit, I really do feel like I'm grasping at straws here, and it's mainly because the ROM on the Mac SE30 doesn't give us any diagnostic information about what might actually be wrong. Anyhow, power's connected, speaker's connected. Here we go. Just immediate failure. Immediate failure. I guess since the sad Mac tone we're hearing here is exactly the same as when this chip was removed, I'm just gonna go and triple check that every single connection on this chip is made to the motherboard. And, you know, like the sound chip, I had left a couple disconnected. I did double check that. Maybe I made another mistake, and then I'll have something to go off of, because right now I have no idea where to go from here. Okay, yeah, there are definitely some connections I missed. It's hard to see because the close proximity to this bar here and the connector, you just really can't get a good view into those pins. So here we go. Let me try to fix this again. All right, well, I'm pretty frustrated right now. There's a short right now between these two pins right here. That pin and that pin. And I cannot, for the life of me, figure out where it is. It's got to be under the chip. There's got to be a solder ball or something on there. And what happened here is I removed the bad chip, well, the potentially bad chip, with this chip quick stuff. And I got to admit, I'll never use that stuff again. It just got all over the place, and it was really difficult to clean up. And I bet you there was just a tiny bit left that I didn't realize was there, and it melts so easily. So when I was resoldering this chip, I guess it melted underneath, and now there's a short. So there's no point to even turn this thing back on right now. I think all the connections are made, but I'm gonna have to remove that chip again. And look how I've melted the heck out of that thing and the connector here, just because there's just not a lot of room there. But yeah, that short is absolutely there, and it's not visible on the top side here, so it's obviously underneath the chip, and I'm gonna have to take it off again. And I'm very frustrated by that. So I often cut this kind of stuff out. You might not see me get frustrated, but I do. I'm human. And doing this type of surface mount stuff is a real pain in the butt. Yeah, like I said earlier, these types of chips here are super easy to take off, put back on. But these PLCC ones, I really struggle with personally. So if you have any tips on how to put these chips back into position when there's all this stuff around them, I'm all ears, because I just don't know. So I'm gonna stop recording now, and I'm going to try to fix this situation now. So hopefully when I'm back, it will be fixed. All right, we're back, and no more shorts. And I did go ahead and double check every pad, and it was connected to the top of the pin on every part of this chip here. So the connections should be good. And I have to be honest, I feel that when I turn this thing on, it's just still gonna be unhappy. And that was not the fault. Here we go. Yep, no freaking change at all. And if we look at what we're getting on the screen, it's exactly the same. Just instant unhappiness. Power cycle the computer. Yep. Incidentally, when I stopped recording to swap one of the chips, I can't remember when I did it, I went ahead and I tested all 5 of these PAL chips in the other board, and they're all good, which is why I put dots on them. There's a little silver dot on each one of these, because those chips are not the problem. In fact, it's funny, I did test the board, the other board, the working one, with taking these out one by one, and only one of them resulted in the system not even making a sound, not even posting. The rest of these, when they were out of the board, just one at a time though, the computer actually had the good chime, like it was working. It's just there was no video. So it feels like these PALs really are handling the video output in conjunction with the video memory, and I think there's a shift register on here, and pretty much the PALs are doing the video output. And frankly, I'm not super surprised that that's the case, because you have to remember that this motherboard is exactly like the one in the Mac 2CX, for instance. And the main difference on the 2CX is it has new bus on it, so it has expansion slots instead of a PDS slot. And the chip here, the VLSI glue chip, actually has a chip select line for the new bus controller chip, and then there's some more support logic that go with that. And you can turn that computer on and it will post a Mac 2CX without a video card installed. So if this stuff is not working, it's basically like there's just no working video, but the machine should still give you a chime. At least I think it should. Now, feeling around for warm things on here with the machine having been on a few minutes, the PALs get a bit warm, but that's really it. I have one more idea actually. Let's check this video RAM chip here. Let's look at the address line, or sorry, the data bus lines, the 4 data bus lines that go to the rest of the machine. Maybe something's wrong with address or data line 31, because that's the one where the 12 volts was on. And we can see it with the oscilloscope. This is kind of the last thing I can think to try right now. Okay, I'm clipped on to data line 31. I'm just taking it off that video RAM chip. It could be off anywhere else on the board. And here we go. Let me power on the computer and let's just see if it looks like normal activity between 0 volts and 5 volts, 5-ish volts. Yeah. I mean, it's a little bit lower than I might expect. We're down around 3.9 volts, but I'm gonna say that that's probably fine. Let's plug in the other motherboard, the working motherboard. Let's see what that looks like. It's kind of useful that I have another motherboard to actually look at here. Okay, so if I push non-maskable interrupt, well, one thing I noticed is that the chime is much faster. Is that relevant somehow? In case you're thinking the clocks are maybe running at a different speed, I don't think that's it, because the video timing is derived directly from all the clocks. And we can definitely see that the video looks correct when we look at the RGB to HDMI, the video we're looking at out of the bad board. And you know what? Look at this pattern we're seeing here. This looks very, very similar to how it looked on the other one. In fact, even the voltages are about the same, 3.9 volts. But I'm not sure if that is actually a problem or not. But this sort of pattern here, while it's sitting at most likely a sad Macintosh right now on this thing, I'm gonna reboot. Okay, haha. So what I did there is I hit reset and I pushed the interrupt button immediately, the non-maskable interrupt button. And what that does is it causes an immediate crash, kind of like what's happening with the other one. And notice that pattern. The chime is slow and that pattern looks the same. That pattern sure looks identical to what we're seeing on the other system there. So we get a pulse, the wider pulse, and then we get 5 of those. Let's just switch back to the other one just to kind of see what it looks like. By pushing non-maskable interrupt very quickly after I press the reset button means that it causes the ROM to halt in exactly the same spot as is happening on this motherboard, the non-working motherboard. The diagnostic routine fails right away on this board, causing that slow chime, and I think this pattern. So here we go. I'm about to turn this on. Remember, 1 short pulse, long pulse, and then we have 5 short pulses. And I'm gonna hit auto. Yeah, okay. It's exactly the same. Oh, and in case you're wondering, it was a little bit wavy at the bottom on the other board because I forgot to hook the ground lead up. So I think it was grounding through the HDMI cable or something like that. But anyways, so based on these patterns, I can make the deduction that data line 31 on the bad motherboard is working fine. The line itself is not held at some weird value due to one of the damaged chips that are on that line. That's what I was kind of concerned of, why I wanted to test the line, because if it was stuck at some weird value, then that could cause the CPU to not be able to access, I don't know, peripherals or test the RAM or something like that. But then what we're left with here is that since I don't understand what the Mac SE30 ROM is even doing when you first power it up, I have no idea what might be the problem here. I was taking a shot in the dark that the 6522, the one that got really hot, was actually bad, but swapping it over from the other board didn't really result in any noticeable difference on the board whatsoever. So I don't know, maybe that chip completely survived and is totally fine. The sound chip was obviously damaged because I replaced that and now we have sound, but that doesn't get us any closer to understanding what is wrong with this system. Having tested several components on the other board, the working board, like all the PALs, the ROM sim, the video ROM, and the CPU, we know those are all good. Sound chip's obviously good now, but still we have a non-working system. I have one thing I want to try, and I'm going to take out the video ROM because I had this in the system here while it was getting 12 volts on everything. And I know I tested this in the other board, but I am just curious to try this video ROM chip here. And let's just, I don't know, it's a shot in the dark, but maybe, just maybe, this will allow this thing to work. I guess what I don't know, and I should probably test this in the working motherboard, is when you have the video ROM removed and you turn on the system, does it crash right away or does it post with just no video? Here we go. Okay, that was no different. Let's switch over to the other motherboard. And let's try it without the video ROM, now the video ROM has been removed. And let's see if we get a good chime or we actually get an unhappy Macintosh. It's my hunch here that it probably will give us a happy chime and will not give us the sad Mac sound. But let's just see. Yeah, okay, so there we go. Good chime. So like the Mac 2CX, which can boot with no video card, this machine can boot with no video card too. And this ROM chip is used to tell the main system ROM how to interface with the video card, so to speak, on the motherboard. And in case you're curious, this is the video output on the working motherboard with the video ROM removed, and we just have absolutely nothing on screen. The reason why hitting reset makes it blank out like that is because there's actually a hardwire from the reset circuit that disables the vertical sync, which on the Mac SE monitor actually shuts down the entire high voltage briefly while the system, resets like that. So that's expected. But without the ROM in there, yeah, we're not getting the initialization of the video, but we're still getting a happy chime. So I was about to wrap up this video when I was looking at the schematics and I noticed on this page, page 2, there are these diodes here that are connecting data lines together. I'm not 100% sure what they're doing here. They all just go to ground. I'm wondering here, maybe this one here, D19, got damaged when the 12 volts was on there. And perhaps it's shorted, shorting 23 to 31. Here are those diodes. They seem to be connected between the SIM sockets. So here is D19, and just check, okay, we're in continuity mode. Is it shorted? No, it's fine. See what kind of diode drop we're getting on here. Let's see, okay, we're getting 0.3 volts diode drop on that one. Let's look at the one next to it. 0.3, and the other pins here, 0.3, and the one next to it, 0.3. Okay, now nothing is wrong at all. That is completely fine. So that's not the problem. So there's one last thing to look at, and it's these traces here that have potentially little breaks in them. Now, I've seen this type of corrosion a million times before, and it's usually just the solder resist on top of the trace, and it's not actually a broken trace. It has to be pretty bad corrosion usually for these little things here to cause any issues. But obviously these are data lines, because we know that this was data line 31 right here, the one that's shorted to the 12 volt cap. You know, when I reinstalled that, I put it right over the traces again. I could have just had it down here and it wouldn't have been a problem more, but that still does make me nervous. Let me just fix that. Okay, much better. The 12 volt cap at least is no longer hovering right over data line 31. Don't know about these two though. One of these is probably minus 12 or minus 5 volts, and that would probably be pretty destructive as well. I'm just going to move this one down as well. There's enough space down here so that it's not going to be touching any of the traces. Okay, I'm going to call that much safer. And it actually looks like a little bit of the solder resist was coming off on data line 31 right there under this capacitor as well. Okay, well, what I want to do is I'm just going to spray some IPA on here, and I'm going to use my little engraving tool here on the low speed just to eat away at these traces here, just to make sure that there's nothing actually broken there. Because if some of these traces are broken, that could easily be causing our sad Mac. All right, yeah, just like I thought. As you can see, there was nothing actually wrong there. There was just a little bit of gunk under the solder resist that was creating a little black spot. But the reality is the traces are actually completely fine underneath there. And since I've now exposed some of that copper, I am just going to put a little bit of lacquer over that for the future, that is. I mean, if this board doesn't work, it doesn't really matter, but let's hope that I will eventually get this board fixed. Over here in this area, we don't really need to worry too much about it. This is all the sound circuitry, and we know the sound is working, and I replaced the sound chip. And let's just look down here by this capacitor. It's a bit of crust around these IC legs. I don't think that's going to necessarily cause us any issues. Not unless something is blatantly broken. And over here by this IC, we have a good amount of flux there. One trace goes underneath there. I think I would have tested that. I always check to make sure that underneath the capacitors that the traces aren't broken or anything like that. And I don't think there was any issue over in this area, or I would have put a bodge wire. Looks like we have a little bit of corrosion over here as well, but overall, not too bad. The whole board is pretty dirty, and that's just because I didn't really give this thing a wash. I just recapped it because I had it in a box full of parts, and I figured I would give it a full wash after the board worked. Which, you know, didn't go to plan because of this little guy right over here. I think we can pretty much be sure that these are those data lines, D31 through D24 or whatever it was, those upper 8 data lines. And they're going to be going to these various chips, the SCSI controller here, I think this is the serial controller, and over here to the sound chips. You see these vias here, they probably go up to this chip, these ones up to the SCSI controller, and then the traces make their way to the sound chip. The fact is, we have working sound, so we know that the data lines are making their way from the CPU past all these peripherals here over to this area. So if there were breaks in this line, it would have prevented the sound from working properly. I was just swapping around some RAM banks, and I think as a final test, I decided just to take out the video RAM chip that got hit with the 12 volts in case it was doing something on the bus. I don't think it's even doing anything yet. You know, during the initialization phase, the video's not being turned on. I don't know, I just figured better safe than sorry just to take it out. The machine should work perfectly fine with that video RAM removed. Obviously, we're not gonna have any working video. Well, at least we'll have half the working video in those stripes, but just better safe than sorry for this little chip here. Okay, here we go. No change. No change at all. Yeah, I was testing out different amounts of RAM. The minimum configuration for the Mac SE30 is 1 megabyte in this bank with 256K. I tried these sims in there. I tried, you know, a full set of, you know, that didn't seem to make any difference. Just in case, like these were bad, that's why I put these in. But no amount of fiddling around with the RAM seems to make any difference. And obviously, with this chip removed, we still have a non-functional computer. I think that's all I can really do for this motherboard right now. Part of the problem is obviously when I recap this, I created that 12 volt short to D31, which damaged chips on this board. That was my fault. Thing is, I don't know if this board ever worked. It was given to me in an untested configuration. I didn't even test it before I recapped it, and obviously, well, once I recapped it, I created that short, which would have damaged the board anyways. So I don't really know if this board had a fault before I even started with it. I don't really know where to go next with this because I don't understand what the diagnostic routine in the system ROM is actually doing. What would be very helpful is that if someone could take a look at the ROM, reverse engineer the SE30 ROM, just to figure out the initialization sequence of the system. And if I could get an outline of what happened at boot, then maybe that would tell me where I might possibly have a fault. We know the video never gets initialized on the system. It doesn't even get that far. So the fault is happening pretty early on in the power on self-test sequence. So if the diagnostic code can tell me that that eliminates, say, a whole bunch of peripheral ICs on the motherboard, I don't even have to worry about those yet, then that might actually give me a clue as to what might be the problem on here. A couple of things I have to just mention in case you're curious. The motherboard does not seem to use data buffers anywhere for the data line. So what comes out of the CPU is directly connected to all the peripheral ICs and the RAM and the ROM and the PDS slot. There are no 74LS245s on this board to buffer the signals between different sections of the board. I guess because the board is so small, Apple didn't really feel the need to do that. I'm assuming when you have PDS cards that plug into here, they probably have buffers on them because you're suddenly adding a bunch of load and stuff that the design of the motherboard is not ready to accommodate. But because there's no 74LS245s, I would probably suspect those having been damaged, but there aren't any. So the CPU is talking to everything on the board. And my hunch is right now is that the CPU is talking to some component on here, one of these peripheral ICs, and is not getting back what it expects based on the code that's in the ROM, and then that gives us the SADMAC. That means the only way I could possibly fix this without understanding what the ROM does is to just do the shotgun approach and start taking off every single one of these peripheral ICs that's on the data bus and taking them off the other motherboard and hoping that that other motherboard has good chips, because honestly, it was battery damaged when I got it, so I don't even know if those chips are good either. So I'm going to put a call out to the community. If you're good at understanding 68,000 code, and you could take a look at the SE30 ROM and start to reverse engineer that initial post phase for me, that would go a long way into hopefully getting to the bottom of what exactly is wrong with this board so I can get this up and running. And in the meantime, the casualties we know for sure from that 12 volt line going into the board were the CPU, the ROM for the video system, and the sound chip. I don't know if that other 6522 is actually bad or not until we get to the bottom of what's going wrong with this system right now. But yeah, that's what I know so far of what I killed by badly recapping this board. So warning to everyone, if you are recapping boards, make sure, just absolutely make sure that you watch this cap right here, the 12 volt cap. And you do not allow this to touch anything around any of those traces because you will damage your board just like I did. So I hope you enjoyed this video. If you did, thumbs up. Huge thanks to all my supporters. Their names are scrolling up the side of the screen over here, I guess. They make it possible to do this full time. If you want to become a supporter, you can do so. The link in the description below. I do have YouTube memberships now, so you can join those as well if you don't like Patreon. And I guess that's going to be that. So, you know, all the usual YouTube junk, subscribe, thumbs up, whatever. And I hope you found this video interesting. I found it kind of frustrating, but that's how it goes sometimes. So thanks very much for watching. Stay healthy, stay safe, and I'll see you next time. Bye.